Hi everyone, and welcome to this Valkyrie sound video on what is the random node. The random node is found in the sound queue, and we can use it to select one sound at random from a list of attached sound waves. So I've got my sound queue into which I've dragged and dropped some sounds from the content browser. I'm going to highlight those, right click, and select random from the menu there. That automatically attaches those to that node. And then I'm going to plug that into the output node. So this is what we get by default. So when I click on the random node, I have several options. We have the weights, with a number assigned to each of the attached inputs. This allows us to change the odds of a particular sound being called. It doesn't seem to matter what weighting system you use. You could use 1 for your top priority and 0.01 for your lowest, or you could use 1 to 100 or 50 to 5000. Basically anything with a higher number is going to have more chance of being played. Next is pre-selected level load. Say we had 100 sound waves connected to this random node, but we have some memory restrictions on the platform that we're building for. We can set this to a value of 0, and it's going to limit how many of the attached sound waves will actually be recognized by the random node, so it won't call the full list of 100 sound waves, only 10 or however many we specify. Those 10 will be selected at random, so we'll still have a degree of randomness in the game. This function only works when the game is actually built. It's not something I can demonstrate in the editor. Next is should exclude from branch culling. This is for the Android and iOS platforms. If we have a look at our project settings here and search for branch, you'll see here that for the Android and iOS platforms, we can specify how many branches we want on our random sound queue nodes. So if we selected that to say 2, and then tick that box here, it's going to weed this so that we only have 2 inputs to this random node. That's going to help to manage memory on mobile devices. Lastly, we have randomizer without replacement. When this is ticked, the random node will remove items from its list of possible options after they've been played. So that removes the possibility of a sound being repeated before the whole sound has been worked through. So if we leave that ticked and play it through, first one, fourth one, fifth, second, third, fourth, fifth, sixth, first, second, third, fourth, fifth, and then it's starting back over again. I'm not so certain that that is 100% reliable, but if we untick this option, it will then just select all of the sounds truly randomly. So you might get some sounds playing twice or more in a row. It's a useful feature to have, and it could be especially useful for weapon sounds and for creating cues that might use ambient NPC dialogue. Because this node is random, it can be tricky to demonstrate, but let's adjust the weightings on some of these inputs. If I give more weight to the last 2, and then hit spacebar to play the cue, you can see that the last 2 waves are going to get more hits than the others. So I'm going to make all of those, so I'm going to make those first 4.2, these last 2 I'm going to leave as 1. If we press play, so you can see that the lower 2 are getting many more hits than the upper ones are. That's quite a straightforward setup, so let's see how we can use the random node with more complex scenarios. Here we have the rifle sound cue from my Cyberpunk Weapons sound pack. In this section of the sound cue, I've got some shell casing sounds. I've split the sounds into 2 parts. We've got the head, which is the initial drop of the shell casing onto the ground, and we've got the tail, which is its skittering away across the ground. Splitting these sounds up and then using the random nodes, I can turn these 6 elements into 9 different full sounds for shells dropping on the ground. The player is less likely to spot then that I'm using the same sounds, just in a different order. So I've connected both the head and the tail to random nodes, and they have equal weighting. And then I've connected the random nodes to a concatenator node, which you can find out more about in one of my other videos. And that's going to go into another random node with lots of empty pins. Now, the random node will always select a sound, even if there's only 1 sound in the list and its weighting is set really low. So if we only want our sound to play on occasion, we can add in empty inputs, and that means it's going to call those, which aren't attached to anything, and reduce the amount of times that our actual sound is going to play. really effective. Very effective. There we are. And you can see as well that I've reduced the weight for that first input, the one with the sound attached, to further reduce the likelihood of that sound playing. So in this setup, I've got our babbling droid sound waves hooked up to some random nodes with equal weighting. Here, and here, and here. I've then used a concatenator node on the top two, so it's going to play first from this selection, hooked up to these three, and then from this connection, hooked up to these three. And for the lower random, which has more inputs, I've added 3 modulators, and you can find out more about modulators and concatenators in my other videos. I've then plugged all of these into a concatenator, and that's going to set the order in which the sounds are going to play. So going from this modulator first, then this one, the top concatenator, and then down to the bottom modulator. My modulator nodes have some pretty wide settings, so we're going to get a really large variety of sounds using these inputs. And the set coming from the small concatenator is going to be in its raw form. They're not going to be modulated at all. So it's going to sound like this. That sort of setup is going to be really useful for sparking electrical sound effects, such as magic or a Sith weapon, or for an energy shield, water, or any actor that requires shifting sounds over a period of time. Notice as well that you can plug a sound wave into more than one of the random inputs. That's going to reduce the amount of memory in the sound queue because we don't need to duplicate our waves. The random node is quite a powerful node because we can use it to create different player experiences with only a limited number of assets, especially when we start coupling it with other nodes. So we can use the random node for footsteps or for Foley, which describes the material sounds that a character makes as they move around a space. We could use it for random NPC dialogue box as well, for ambient sounds, for the audio that a computer makes when a player interacts with it, or for mimicking something like the speech in a game like Animal Crossing. And that's it for random nodes.